SciCuriousID presents a journey into the bizarre and fascinating world of quantum mechanics. Imagine a cat that's both alive and dead at the very same time. It sounds like something straight out of a fantastical tale or a far-fetched science fiction novel, defying all common sense and our everyday understanding of reality. However, this seemingly impossible scenario is actually at the heart of one of the most profound and strangest ideas in the entire field of physics. This is the famous thought experiment known as Schrödinger's cat, a brilliant and unsettling concept designed to reveal the truly mind-bending and counterintuitive logic of quantum mechanics.
Behind every question lies discovery. I'm Saluna, and this is SciCurious, where we uncover the science shaping our world.
Back in 1935, the brilliant Austrian physicist Erwin Schrödinger conceived and presented a story so utterly strange and paradoxical that it quickly became one of science's most enduring and famous paradoxes, challenging the very foundations of how we perceive reality. At that particular time, quantum mechanics was a revolutionary and brand new theory, still in its nascent stages, attempting to describe the fundamental and often perplexing behavior of atoms and the even smaller subatomic particles that make up everything around us. But this groundbreaking theory also put forth something truly shocking and difficult to grasp: that these tiny particles could exist in multiple states simultaneously, a phenomenon that physicists termed superposition star. This meant a particle could be in two places at once, or spinning both clockwise and counterclockwise until observed. Schrödinger, a keen observer of the world, wanted to vividly demonstrate just how absurd and nonsensical that quantum concept of superposition sounded when it was hypothetically applied to the much larger, macroscopic objects of our everyday, tangible world. So, let's delve into the specifics of how his ingenious and unsettling thought experiment is supposed to work. You begin by carefully placing a living cat inside a completely sealed, opaque box, along with a small, precisely measured piece of highly radioactive material. The setup is designed with a deadly trigger. If even a single atom within that radioactive material decays, it will instantly trigger a Geiger counter or similar detector. This detector, in turn, activates a mechanism that releases a lethal dose of poison gas, tragically killing the cat. Conversely, if the atom does not decay within a specific time frame, the detector remains inactive, the poison is not released, and the cat inside the box continues to live, unharmed and oblivious to its precarious situation. Now, here's where the quantum weirdness truly begins. According to the principles of quantum theory, until you actually open that box and observe its contents, the radioactive atom inside is considered to be in a superposition, meaning it is simultaneously both decayed and not decayed. And because the very life or death of the cat is inextricably linked and directly dependent on the state of that single, uncertain atom, the cat itself must also exist in a quantum superposition. It is, therefore, both alive and dead at the same time, existing in two contradictory realities simultaneously within the sealed box. It is only at the precise moment you open the box, when you actively observe the system, that this quantum superposition, often referred to as the wave function, collapses. This act of observation forces one of the two possible outcomes to become definitively real and manifest in our observable world. The crucial and most profound idea embedded within this thought experiment is the concept of observation itself. In the strange and counterintuitive quantum world, the act of measuring or observing something doesn't merely reveal its pre-existing state. Rather, it actively defines and determines that state, bringing it into being. Before you look, before any observation is made, reality at the quantum level exists as a realm of probabilities and potential outcomes. But the instant you observe, those fluid probabilities instantly solidify and coalesce into a single, definite, and undeniable event, fixing reality into one specific state. It's important to remember that Schrödinger never intended for this to be a real, practical experiment. He was, in fact, a great lover of cats. It was conceived as a brilliant parody, a reductio ad absurdum, specifically designed to highlight and expose how utterly bizarre and illogical quantum mechanics becomes when its principles are extrapolated and applied to large, everyday objects like a cat. However, despite its initial intent as a parody, the fundamental principle behind it, quantum superposition, is surprisingly and demonstrably real. Physicists have, through countless experiments, observed quantum systems behaving exactly this way, using not just atoms and photons, but even complex molecules thousands of times larger than simple electrons, confirming the strange reality of superposition. Here's a fascinating fun fact. Schrödinger's cat paradox directly inspired the scientific term quantum decoherence star. This concept describes the process by which delicate quantum superpositions vanish and collapse when quantum systems interact with their surrounding environment, much like a perfectly formed wave instantly losing its coherence the moment it touches air or light, solidifying into a single state. Different scientists and schools of thought interpret this profound paradox in various ways. The widely accepted Copenhagen interpretation, for instance, posits that the very act of observation is what causes the quantum wave function to collapse, forcing a definite outcome. In contrast, the intriguing many worlds interpretation suggests a far more radical idea, that both outcomes actually happen, but they occur in separate, diverging universes. In one universe, the cat lives, healthy and content. In another, a parallel universe, it tragically does not survive. Ultimately, Schrödinger's cat isn't just a clever joke or a scientific curiosity. It's a profound window into one of the deepest questions in physics and philosophy, whether reality itself continuously splits and branches every single time a quantum choice is made or an event occurs. So, the next time someone brings up the perplexing concept of Schrödinger's cat, remember this crucial point. It's not truly about the fate of the cat at all, but rather a powerful metaphor for the fundamental nature of reality. It's about understanding how reality works at its most fundamental, subatomic level, a place where what seems impossible in our everyday experience is not forbidden, but merely waiting for the act of observation to bring it into definite existence. Are you curious for more mind-bending scientific insights and explorations? Then be sure to subscribe and continue to stay curious with SciCuriousID for more fascinating journeys into the world of science.
There's always more to discover. I'm Selu, and this has been SciCurious. Stay curious, and I'll see you in the next wonder.